So, oh, there. Okay, so on the group meeting, let's see. Okay, so I'll read the first one. When taking
Okay.
samples of n when n equals 5, what is the shape of the distribution means histogram when the parent population is right skewed? So, what is the shape of the, is it
History.
still right skewed? Because if you
Correct.
don't, well, because it's, your sample size is still small, so it doesn't correct it.
Right.
So it should still be that, right?
Yep.
Okay.
I can read the next.
Okay.
When taking samples of n equals 100, what would the shape of the distribution of means histogram be when the parent population is right skewed? Well, then it would be normal
Right.
because it's above 30.
Okay. Josephine, you want to read number 5? Are you with us?
Yes, I'm trying to log into my page.
No. Okay. All right, I'll read 5 while you're getting in there. When taking samples of n 100, what is the shape of the distribution means when the histogram when the parent population is normally distributed? Well, then it's still normal.
No.
And do 6, right?
Yeah. When would the distribution of means be normally distributed? Choose all correct responses. So the data are drawn from a population that's normally distributed and the sample size is small. So that works
That's
if
true,
the parent population is normal.
right?
Data are drawn from a population that's normally distributed and the size is large. That works. Data are drawn from a population that's right skewed and the sample size is small. That does not
That
work.
one's not.
But the last one works. Data are drawn from a right skewed and the sample size is large.
Yeah, okay.
Okay, so I have to read question 7.
Okay.
Okay. Which of the following gives the best explanation of the central limit theorem? Um, can you guys please help me with the answer?
Yeah.
Shape. Let's see.
I think it's if the sample size is large, the sample. Wait, no, this is central mean. No, sorry, central limit theorem.
Yeah, that's what I have written on my notes. As the sample size n increases and becomes large, the distribution of the sample means becomes approximately normal.
Yeah, so if the sample size is large, the shape of the sampling distribution will be approximately normal. Did you get that, Josephine?
Yes, I did.
Does that make sense?
No, actually, I haven't even had time to go through the lesson material at all.
Oh, okay.
All right,
So,
yeah.
yeah, basically there's two rules they want us to know. One's the central limit theorem and the other's the law of large numbers. And the central limit theorem talks about the shape of the distribution, and then the law of large numbers talks about how close the distribution is to the true mean. Kind of, that's my short summary of it, but you'll get more out of the reading.
Alright, I'll do that. Thank you.
Yeah.
Just a minute. I'm texting Becky quick. Becky, can you hear me? She says she can see us, but she can't participate. Can you hear? If you can hear me, send me a text message, Becky. Oh, she can hear us. Remember when Soraya joined that one time and she had the same problem and she could see us but not hear us or something like that? And she said she just exited out and rejoined over and over until it finally connected, and I'm not sure. That's the only thing I know what to tell you. But otherwise, Becky, don't worry about it. I'll put your name on it, and she's never going to watch it and see anyway. Okay,
And
so
she can download it from YouTube if she wants to watch it.
okay, so let's see, 8. So x be a random variable with a population mean of 10 and the population standard deviation of 6. Suppose a sample size n 36 is drawn from the population. What is the mean distribution of the sample mean? So the mean is still 10, right?
Yes. So number 9, what is the standard deviation of the distribution of sample means?
So
is this where we have to do our little formula?
yeah, so this one, so you take 6 and divide it by,
So it'll be 1.
No, 10.
Well, it's this.
Oh
Use
yeah,
the standard
6
deviation.
divided by the number. So
Yeah.
6 divided
Divide
by
the square root of
square root.
36.
So I got
So it's
1.
1. Yep.
Okay. All right, Josephine, you want to read 10?
Yes. Regardless of the distribution of the population, if the sample size is large, n is I think lesser than 30,
Greater
what
than.
should be the shape distribution of the distribution of the sample mean?
So the trick there is because it's greater than 30, you're going to be normal.
Yeah.
Because anytime you have a greater than 30, whether it's a normal distribution or a skewed, it's normal, right?
Yeah. And that's kind of one of the big takeaways from the lesson is you just want to have a big sample size because then it takes care of anything else.
All right. So what theorem would justify your response to question 10? Well, that's the...
That'd be central limit theorem, wouldn't it?
Regardless of the distribution. Oh, because it's shape. Yes.
Right,
yes,
because
yes,
it's
I
shape.
think. Uh-huh. Okay, I agree.
All right. So I think it's my turn to take the bullet, right?
Oh, I'm not too worried. Okay,
Oh, I
go
got
ahead.
And we got them all right.
Good. All right. Sounds good. So, Josephine, we're trying to meet Tuesdays and Thursdays at noon. So, instead of changing around, that seemed to kind of work. So, we're just going to kind of stick with that. So,
Okay,
That'd be
I'll
all
try
right?
and come around.
all right. Sounds good. Okay.
All
Thanks,
right, see you
Ryan.
Thursday. Bye.
Okay. See ya. Bye.
Bye.